Good afternoon to everybody on the line today. Welcome to today's webinar presented by Husky Injection Molding Systems. I'm your moderator, Christina Fugis with Mold Making Technology, and I have to start off by saying we appreciate everybody out there taking the time to be with us today. So today's webinar is called The Fundamentals and Benefits of Hot Runner and Controller Maintenance and Refurbishment, a hot topic nowadays with our readers. It's going to cover key maintenance practices for hot runner systems that help molders operate at optimal performance levels, temperature controller setups and settings that result in fast and efficient startups, and recommended procedures that minimize downtime and extend hot runners and controller life. Today's presenter is Derek Hennebeek. He is the Hot Runner product manager for Husky and responsible for new product launches, specialty applications, and product portfolio management. Now, before I pass this over to you, Derek, I want to remind everybody listening that this presentation is being recorded so you can listen to it later on. And you can ask questions all throughout the presentation by just typing them into your questions panel. And then when we are finished the presentation, we will go into the Q&A mode and Derek will try to answer each one. So that's about it. Derek, I'll turn it over to you.
All right. Thanks a lot, Christina. So yeah, hello everybody. Welcome to our webinar. As introduced, my name is Derek Hennebeek, Hot Runner Product Manager for Husky Technologies. And a big thank you to Christina and the rest of the team at Mold Making Technologies for the opportunity to present today. So today we'll talk about the fundamentals behind hot runner maintenance and refurbishment. And we hope that after the webinar, you can recognize the benefits of hot runner refurbishment, extend your knowledge of what procedures hot runner refurbishment entails, learn how to minimize downtime and extend hot runner operating life, and know more about Husky's service offerings regarding hot runner refurbishment. So a few notes about Husky itself. Husky is an industry-leading company manufacturing hot runners and temperature controllers for mold makers, converters, and brand owners. We have facilities in key manufacturing regions of the world. We utilize standardized engineering and manufacturing to ensure consistent product and performance anywhere in the world. We make unique products. For example, our temperature controller technology utilizes superior measurement and control accuracy with scalable software to provide for growth without needing to replace the entire unit. And we serve a variety of market segments and work with several different applications. Each of these have their own unique solutions when it comes to thermal management and melt delivery. Our experience across those market segments gives us a very good understanding of the maintenance and refurbishment needs for those applications. In addition to typical hot runners with hot tips or valve gates, Husky also designs and builds hot runners for specialty applications like angled drops for large parts with highly contoured part geometries, drop-in systems for simplified plate designs, side gates for narrow, long draw parts, and stack molds for high outputs with reduced machine footprint. Just like the variety of options available in hot runner and melt delivery technology, service and refurbishment recommendations also vary depending on application. We see thousands of resin grades, each with different effects on hot runner components and requiring their own needs when undergoing refurbishment. Refurbishment is the replacement and refreshment of components. This can be done on a regular cycle schedule, time interval, or an as-needed basis. This is done because equipment wears out over time. All of us in production molding recognize equipment and tooling are in a constant tug-of-war custody battle between various opposing conditions. Hot and cold, like turning molten resin into solid parts, moving and static, like suddenly opening and closing molds, or loaded and unloaded, such as engaging tonnage or filling cavities. Also, molten plastic is pretty much liquid sandpaper. Applications with glass or mineral fillers can magnify those effects too. Some resins are corrosive when molten or overexposed to heat. For example, Brominated or halogenated flame retardants will attack steel integrity at any temperature. Now let's explain why maintenance matters. Maintenance is important for any technical asset that creates a deliverable and uses components with limited operating life. Regular maintenance minimizes downtime. With planned maintenance, risk of unplanned production interruption is minimized. Planned downtime is typically shorter and less frequent than unplanned downtime. Regular maintenance also preserves process window. By ensuring all systems are in good working order, the entire operation is less sensitive to outside influence. This results in better consistency and overall part quality. Finally, regular maintenance extends the life of your equipment. These assets, after all, are investments. They're not just tools to make parts, they're tools to make money. If you take care of your equipment, it takes care of you. Many of you are probably experienced or aware of the need to maintain your molds. There are surfaces that touch your part and dictate quality and finish. As parts wear over time, the need to maintain or refurbish becomes very apparent, and it's a standard expectation. What many people don't understand is how refurbishing the hot runner also has an effect on that plastic part quality, just like the mold. And like mold refurbishment, hot runner refurbishment can restore operation and expectation back to 100%. It also assures continued part quality, like seen at qualification. Uptime expectation should now increase, since you know the hot runner has been rebuilt and inspected. This should extend the operating life of your equipment, or another way to achieve longer equipment life is to modify it for a new application or adopt new technology. In our picture on the right, we can see our hot runner tips have some clogs and burn material, with some corrosion apparent on the heaters. Other factors may also prevent the mold from running as well as it should, but refurbishment brings it back to like new condition. A hot runner refurbishment can cover a wide range of tasks, from a general cleaning to a complete overhaul. Each has its own advantages, costs, and timing. A basic cleaning is typically the minimum. The hot runner is dismantled and melt stream components are immersed in a fluidized bed to remove old resin. The manifold is then washed to remove the bed sand, heat tested, and returned to the molder for reassembly. This may be done for tools that slowly develop burning or melt contamination or fill imbalance over time, um, you know, and that they'll do it steadily over their operating life. A hot runner preventative maintenance, or PM, takes that a little bit further. Um, Adding an inspection step to ensure components are still within spec and to ensure tip or stem heights. Single-use wear components, which we'll cover later, will also be replaced. A rebuild takes that preventative maintenance even further. After cleaning, inspection, and single-use components are replaced, so are continuous use nozzle components like valve stems, nozzle heaters, and tips. Finally, there's a complete overhaul or restoration. Nearly all components in the hot runner are replaced, including wiring and connectors. This is essentially a new hot runner at a much lower price. Many hot runner suppliers will offer to reinstate a warranty period with this kind of service. Conversions are another type of refurbishment where a prearranged hot runner design can be modified to meet a new application. This might be a cavity expansion where the hot runner now delivers melt to 2 or 4 cavities, or a conversion to change a single-faced hot runner to work with a stack mold. If a mold frame is being changed, its hot runner might be modified to handle the new throughput or a different material. But these are very specific changes which require planning and insight. So these goals are best discussed with your supplier before purchase, but they can also be investigated by your supplier's sales and support team. Properly maintained, hot runners can be used for a very long time. We frequently field questions for hot runners more than 15 years old. Verifying conditions can be used to benchmark performance and develop expectation. These should be done over regular time intervals and evolve into a cycle count based on performance and observation. And this is just because application has a major influence. For example, a packaging application running a 150 melt polypropylene with a hot tip on a 6-second cycle can see very different conditions compared to a 7 melt polycarbonate with a valve gate on a 14-second cycle. For one thing, the static parts of a hot tip see different types of loading than the moving parts of a valve gate. The parts and their designs are unique to their intent and their application. So what I'm saying here is just because it's molding plastic parts, that doesn't mean the same exact blanket expectations should apply. I'll go over some of those specifics in the next couple of slides. 6 months is a good baseline to start to consider for inspection. This can evolve with application, observation, and previous program performance or experience. For example, corrosive resins may warrant a more frequent inspection based on usage, temperature, and cycle time. Every 3 to 4 years of cumulative run may be a good baseline interval to consider a complete overhaul. Again, this might see some up and down due to application. To manage issues or failures as they occur, it's good to have about 25% spares on hand when it comes to replaceable or single-use components. This is a section view for a thermal gate or a hot tip nozzle. These are stationary assemblies with no moving parts, so they have very few single-use components. These are parts that can wear out over time due to repeated load, and they should be replaced once removed from the hot runner. Nozzle tip insulators are an item that should be replaced anytime they're removed from the hot runner, and they're easy to access by splitting the hot half from the cold half. These are used to minimize gate bubble volume for heat-sensitive resins or to improve color change. Reusing them might cause them to crack, which can create stagnation areas and streaking. Disc springs are another single-use component that should be replaced if removed. These directly influence the preloads that prevent resin leaks. Backup pads influence preload and tip heights, but they're much sturdier. They should be checked for wear to confirm no gouges or hobbing. These are continuous use components, meaning they can be used with repeated removals, which is why they're labeled in green. The nozzle heater is a critical component that supplies heat to the drop. Its resistance and duty cycles should be noted and checked regularly. A failed nozzle heater can cause cavity imbalance, short shots, and decrease the overall output of your mold. Finally, the nozzle tip is actually made of 2 components, an insert and a retainer. Both are continuous use parts, but they have separate functions. The tip insert transfers heat to the gate, and its relative position is critical. This has a direct influence on gate quality and cavity balance. The retainer holds the tip insert in place, but it also acts as a seal ring. That contains the gate bubble and ensures resin flows into the cavity, not back over your nozzle heaters. If these have gouges or flat spots, they should be replaced. This is a section view from a valve gate nozzle. These are used to mechanically control the gate for superior gate quality and process control. Several components are common and have the same functions, but because valve gates depend on movement to perform their function, they have more single-use parts. So while here we show an individual drops piston, These suggestions also apply for plate actuated or hydraulic actuators. The crush ring and the graphoil seal prevent air leaks. These ensure reliable performance for gate opening since excess air leakage can decrease efficiency, and they permanently deform when installed, and they cannot be reused. The piston seal is also a single-use part that should be replaced if removed. This controls the stem actuation in both directions. Age and excessive wear can prevent efficient movement and affect repeatability. So worn piston seals can also prevent the valve stem from completely closing, and that can show up in a part defect that some call high gates or posting. Finally, the valve stem controls the gate itself. This is a continuous use part, and it can be used so long as it's not damaged. Stem positions should be checked to ensure that they close all the way, but the condition of the stem should also be checked because worn stems can lose their shutoff and gate quality can suffer, which is often a critical part feature. Hot runner refurbishment may sound like something only possible for a specialized facility with exotic equipment, but some work can be done on site if you have a workbench, tools, and crane available. In some cases, you might outsource the hot runner for a full overhaul. The refurbishment will be reliably scheduled, performed, and confirmed by experienced technicians. And in other cases, you might perform that preventative maintenance or inspection yourself. This can save shipping costs and minimize turnaround time. A side benefit from regular on-site refurbishment is accelerated troubleshooting if an issue develops over time, no matter the root cause. To do this, it's a must to decide what you can and cannot do. What work will your team do on site, and how far are they going to take it? What will be outsourced? Is your team trained to do the work, and do they know what to expect? Do they have the right tools? Are drawings, bill of materials, and manuals on hand? These are all references you should have available so you can know your part numbers, inspection information, and torque specs. Finally, scheduling and preparation are very important. Though your team might dismantle and reassemble the hot runner, you'll probably need to outsource the manifolds for cleaning. Confirm your manifold cleaning provider has your work on schedule and that they can bake out your resin. Preparation is key. Be sure you have all parts on hand and spares in case things break or fail. This will minimize your downtime and your risk. Periodic inspection is the best way to minimize surprise. This ensures the hot runner is in good working order and flags what may need replaced or double checked at the next scheduled interval. As applications exhibit different wear conditions, but 6 months is a pretty good interval to begin benchmarking. Some of these things can be done in the press, but others might be easier to do with the mold pulled. Machine interface conditions should be reviewed. So make sure the locating ring is still in good shape with no nicks, burrs, or gouges. The sprue bushing should also be checked to confirm no leaks or gouges at the machine nozzle's spherical radius. Resistance checks should be performed, recorded, and compared to the hot runner's electrical schematic. This can sometimes be done through the temperature controller. Heater duty cycles should also be checked, and if they differ from the previous inspection, consider replacement. Manifold preloads along with tip and stem heights for each drop should also be checked, recorded, and compared. These are best done in the cold condition, and this information and their tolerances can typically be found on your hot runner's assembly drawing. Finally, a visual inspection of those gate controlled parts should be confirmed. Make sure that your tips, stems, and seal rings are not gouged, dented, or cracked. These have a direct influence on your gate quality, and they might explain some of the root cause of issues for a problem cavity. Outsourcing may provide the most peace of mind. Turnaround time might be a little longer, but there's value with experienced technicians performing a refurbishment with resources dedicated specifically to that end. There's also a decreased risk in unexpected delays, and downtime is more likely to follow your schedule. So I'll go over some of Husky's basic refurbishment steps just to give an idea of what we do. We have an established process to support refurbishment. Depending on planned service, inspection is done upon receipt and dismantling and proceeds every step of the way with feedback provided if something needs to change. For a complete overhaul, some of these steps may be skipped or abbreviated since all the nozzle stacks and wiring are replaced. Our fluidized bed technology offers an environmentally friendly solution to cleaning plastic from your melt transfer components. This is a service that's commonly outsourced to us, and rightfully so. It's a pretty serious piece of equipment to purchase. This is a non-abrasive procedure that burns away and vaporizes plastic. The manifold and melt components are removed from the hot runner and immersed for several hours. This is an extremely effective and efficient way to remove resin from a manifold. It doesn't require torches, hammers, or chisels. It also eliminates the need to remove plugs or to drill out melt channels, because all of the above there can easily damage the hot runner, and that'll drastically hurt its performance once you rehang it. Some materials may require additional or alternative methods. That's because they have restrictions based on regional environment requirements. And that's why it's important to discuss with your coordinator about regulations and forward a material data safety sheet. Following the resin cleanout, the manifold is extrude honed and washed. A silica-based slurry is injected at high pressure to clear away loose debris, and it polishes any burrs that could remain in the melt channels. If any blockage remains in the channels, it's very easy to recognize it for corrective action. The manifold is then bore scoped. A tiny, flexible cable camera is inserted and probed through the melt channels. If any blockage exists, it can be quickly identified. This can also identify areas with a high amount of erosion and to confirm melt channel plug quality. If any issues are observed, repairs and replacement can be proposed. Again, depending on services, many things can be done. All parts can be replaced for a full overhaul or only on an as-needed basis. Inspections can be bypassed for the sake of time, but if we see something, we say something. Once the manifolds are cleaned, the hot runner is reassembled and rewired. Preloads, tips, and stem heights are checked and recorded to ensure they're within spec. And if applicable, air circuits are checked to confirm that all valve stems actuate properly. Finally, the hot runner is heat tested and checked to ensure that all electrical circuits are complete and all the electronics perform as they should. Refurbishment applies not only to keeping the same hot runner for the same application, but can apply to various conversions and retrofits. This can be done if the L dimension or the nozzle length needs to change in case a cavity plate is resurfaced, when a material changes to a completely different family, for cavity expansion to convert a single cavity prototype to a multi-cavity production mold, or transferring that hot runner for use in a completely different mold or application. In these cases, a platinum refurbishment applies best because that can reset the hot runner back to its original 3-year leak-proof warranty. Now, hot runner refurbishment not only applies to sending the hot runner back to the factory, but it can also be done on-site at your facility. A Husky technician can be scheduled to work directly with your team. Parts can be ordered and sent to you in advance for that scheduled downtime. This should save on transport time, but another benefit is immediate training and support directly provided by an experienced and seasoned Husky team member. So we hope that you found the information in today's webinar useful for improving your understanding of the benefits of hot runner refurbishment, expanding your knowledge on how much or how little effort hot runner refurbishment entails, that you learned more about procedures and recommendations to minimize your downtime, and that you gained a better understanding of Husky's hot runner refurbishment offering. So please note that at Husky, we have a specific team for managing hot runner refurbishment. So they, our call desk, and our sales team can all answer questions about refurbishment at any time. So thanks for your time and your attention today. If you'd like to reach out to learn more, my contact information is at the bottom of the slide, and feel free to reach out at any time. So now we'll take some questions and have some healthy discussion about anything we might have missed or further details about everything we've just covered.
All right, Derek, thank you. Why don't you come back up on the screen?
Will
Before
do.
we jump into some Q&A, I want to remind listeners that we have a few polls that we'd like you to take some time to go to the poll tab, answer a few of those poll questions to kind of give Husky a scope of who you are and where you stand with your hot runner systems and your maintenance plan. So do that for a few minutes. All right, let's get into this. Oh, and I want to remind people that until we have plenty of time, so continue to think about what Derek presented and just type in questions into the questions pane, and we will run down them as they come in. All right, so Derek, let's see. Why don't we start off with, all right, from time to time, we receive older Husky hot runner molds and controllers. Does Husky provide a service to inspect and bring the systems to like new and certify the equipment's condition?
Yeah, so the short answer is yes. We get a lot of questions on older hot runners and controllers, quite a lot. A couple of weeks ago, I saw. I know that we fielded questions for a system that was built back in 1992. So
Wow.
what we can do is, we can. So what we can do is we do provide the service to inspect, to clean, to refurbish, and to bring that to like new condition. What we do is we pull the drawings, we go through everything, we check all the tip heights, stem heights, melt channels, everything like that. If anything needs to be replaced, if it's just an inspection, we'll provide feedback on what needs to be done, or if it's a complete overhaul, we can pretty much take it from there. Myself, in my past, I've seen systems going back to the late 70s, so it's not an uncommon thing to have an older system that needs to be reviewed, that needs to be refurbished, and brought back to like new condition.
On a related note, have you seen over the past few years, I mean, it really is a hot topic with our readership. Have you guys noticed just an increase in tool rooms really focusing on having concrete, like preventative maintenance plans for their hot runner systems?
Yeah, I think everyone is trying to keep everything going, and there's a lot more interest in maintaining equipment. That's I think that's just something that we're seeing across the industry today. Training is more important than ever. Experienced
Yeah.
people are more important than ever, and it really helps when your team, when your boots on the ground, knows what's exactly inside your mold and inside your hot runner and how it works from front to back.
Yeah. Yeah. All right. Can side gates be used for PA6 glass-filled resins?
Sometimes that's
Mhm.
going to need to, that of course is an application question. That's a really good question to run past a salesperson, but In my experience, I know that they've been done from time to time. Those just need some very careful review when it comes to mold design, especially early on, just to talk with whoever is making that side gate to make sure that that everything's going to work hand in hand.
Okay. What are the different valve gate actuation types and what are their, can you review their limitations and benefits?
Sure. Um, Valve gates can be actuated a number of different ways. There are a few methods, and then I call them methods and vehicles. So for methods, that can be done with pneumatics, hydraulics, or electric servos. And then the vehicles are really how are those stems moved? Those can be moved individually, or they can be moved as a team. So a standard or a very typical hot runner will typically have an actuation, typically a pneumatic actuator, but all of those valve pins can be tied to a single plate, a lot like an ejector plate that lives inside the hot runner.
Mm.
That's what we call our UltraSync product. Each has its own positives and negatives. The usually shut height is your mold, your hot runner is going to be thicker if you've got a plate actuated system, but you're also going to see a lot more consistency when it comes to those systems.
Okay. Is there any possibility to anticipate leakage using controllers?
Yeah, um, uh, that's a short way to put it, but your controller is really good at not just controlling how much electricity is flowing to your hot runner, to your heaters. Your controller can also be used to monitor your heater status. So you can use you can use your controller to monitor heater resistance. If you see a change in heater resistance, that means that something about that heater has changed.
Hmm.
Um, that would warrant a pretty good follow-up. At the next scheduled shutdown, you might need to take a look at that, maybe even replace that heater. Another really good feature that temperature controllers provide nowadays is an output for duty cycling. So that's how much power does a heater need in order to do its job, in order to
Mm.
satisfy the thermocouple that it's at temperature. Um, if you see that the duty cycle on a heater has increased, sometimes even significantly, that could indicate that there might be that that something is going on at that area. Typically, this is at a nozzle. So if there's a leak beyond the seal ring at the nozzle, that means that a heater is encased in plastic. Um, Plastic is a good insulator, but it's not nearly as good an insulator as stagnant air. So in that case, that could indicate that you might have a leak and that you might want to check that out uh, either at your next scheduled maintenance interval, or you might want to crack that open and get to it as soon as you can.
Can you provide an explanation on why the orifice of sprue bushing hot manifolds are larger in comparison to injection molding machine nozzle orifice?
Um, that that's multifaceted. So with a cold runner, you're freezing your runner with every cycle, and you want to keep that sprue bushing orifice as small as you can because that's typically the last thing to freeze on a cold runner because that's typically the thickest component to that cold runner. With a hot runner, you typically have larger channels because you're not trying to freeze it, and your larger channels are also that size in order to control the pressure that's going through in order to get from your machine nozzle to your gate or to your cavity. Um, Myself, I feel kind of strongly that you should go size on size between your machine nozzle and your sprue bushing whenever you can. I feel also that it's good to have that as large as possible, just to minimize any other pressure losses. After all, why choke that flow down any more than you need to? Because that will help to keep your pressure down. It'll also help to keep your temperatures down, which can help to keep your cycle time down.
You did good covering that multifaceted question.
Thanks.
All right. For multi cavity, what is the standard variation in gate size?
That's uh, that's really going to depend on a lot of other things. So that will depend on part weight, wall thickness, and material itself more than it would affect more than it would depend on cavitation um, or uh, or the gate size itself, really. So
Mhm.
that's a question that would need a lot more background. Um, that would be something that would be best followed up with maybe with a what we could do is we could put you in touch with a sales contact to go over that application, look a little bit further into something like that.
Okay. What would be the life of a valve pin? 1 million, 5 million, or until it shows wear, wherever that wear may be.
That's the short version is the last one. So until it shows where, but you know the first part of that is a completely reasonable thing to ask, and that's going to really depend on application. That's going to depend on the type of material that you're molding. That's going to depend on the type of cycle that you have, and that's going to depend a lot on your process. So if you have a valve pin, it's also going to depend on your valve pin shutoff. If you have a, a conical or a cylindrical shutoff, so we see this a good bit where um, in some cases with valve gate molding, you can see posting forming, and that's because the hold time is too long. Well, you might see a lot more wear on those valve pins earlier because what you're really doing is you're closing on cold material. In that case, you might see significantly shorter valve pin life than you would on the same application if you had some larger gates so that you could uh, make sure that material doesn't freeze as quickly, or if you had a shorter hold time to make sure that you're not slamming that valve pin home on cold material.
Hmm. Here's a general one. When is the best time to PM my hot runner system? And what does the downtime typically look like?
Um, that's going to that's going to depend a little bit on what you're doing and what you're seeing. I always recommend to start out at 6 months as an inspection interval. So try to take a look at everything every 6 months and give things a good once over, as mentioned earlier. Um, Take a look at your interfaces, check out your heaters, take a look at your tip and stem conditions, and also make sure that your part quality is still within spec and within needs. So so when it comes to time interval, I would say 6 months is a good place to start, and then adjust from there. Um, get an idea of your history, and if once things need to be checked out, now you've got a better idea of what you did before and what you need to do the next time. Uh, Long-term overhaul, that's really going to be more of a that's where our 3 to 4 year recommendation as a benchmark comes up. Uh, Once again, it's going to depend also on application, downtime, that sort of thing. Um, the other part of it is it depends on where you are. And uh, if you send a hot runner back to your supplier, you're going to either need to start to take it apart yourself. So you put just the bare minimum on a truck, or you're going to package that thing up and possibly send it all the way across the country. That's all going to depend on how much you pay your freight forwarder.
Hmm.
But it also depends on complexity. So if you have a two drop valve gate, that's going to be a lot different than the turnaround time for a 128 drop hot tip.
It is a lot of data too. Like
Yeah,
it's them knowing the mold in the system. Are there
right.
specific data points that they should be mindful of to help make those decisions?
Absolutely. Knowing what you've done in the past is really important. How much have you replaced? How much is broken? And what's been seeing challenges? Is it a certain cavity? Is it a certain drop? All of those things can really help to do some troubleshooting, but it can also give you an idea of what to expect once things come back around.
All right, how many cycles can a hot runner run without any type of system maintenance?
That's that again, that depends. That depends on how hard you're beating it and how hard you're working on it, and how much you're neglecting it. Some systems can probably go 1.5 million, but we've got some systems out there that have been running for 15 million. Um, they still haven't needed to be taken apart or refurbished.
That's a good promotion for that, right?
Yeah, yeah, it is. That's pretty impressive.
That's very impressive. All right, what is typically the clearance between the valve pin and the seal behind the nozzle to prevent leakage after factoring in heat expansion?
That's that's a number that I don't have off the top of my head. So that's probably going to need a follow up, a discussion, um, and that's probably going to be application dependent in itself.
Okay. Can I order parts from a different supplier to use in my Husky Hot Runner refurbishment?
That's a that's a yes and no, and that's also there. That's the difference between yes and no, and that's the difference between can and should. So. Um, Aftermarket parts for anything in any any application, whether it's injection molding or in your car, has its own risks. So in the case of a Husky Hot Runner, if you're buying aftermarket parts from somebody else who's not Husky, we Husky doesn't know what's in there, what's on there. There could be some differences in tolerance. There could be some difference in material properties. There could be differences in coatings. All of those things are going to, if anything, all of those differences are going to stack up, and they may magnify an issue, or they may make an issue a lot more difficult to troubleshoot if you have a smorgasbord of different suppliers um, all across the drops on your multi-cavity system, just because each of those little things is going to have a little bit of differences, all of which are going to accumulate to sometimes one big problem with a history that's really really difficult to backtrack and troubleshoot.
Yeah, that makes sense. I mean, it's very hard to know what you're working with, right? The more you have that's not from the same source.
Exactly. Yeah.
Yeah.
Yeah. If we don't know what's there,
Yeah.
it's really really difficult for us to to project or to predict an outcome.
Yeah. All right. Gate vestige. What are the causes? What should be inspected and potentially replaced? And what are the process contributions to gate vestige?
That's a long one. we
There
we we could probably do a webinar just about that.
you go.
Um, so that's going to depend on, are you talking thermal gating or are you talking mechanical gating, hot tip versus valve gate, um, and what kind of material are you talking about, what kind of parts are you talking about, and what kind of process are you currently running. um, One of the things that I always recommend is when you're inspecting, you, like mentioned earlier, always check your hot runner nozzle components. So check your tip heights. So that's how far do your tips protrude from the hot runner interfacing surface. Also check your stem heights. So how tall are those from that same surface? Um, those are designed with a certain spec in mind, and those are designed to interface with your gates with a certain performance that's anticipated. Um, if things aren't matching up, so the let's say the gate height is expected at a certain spec. Maybe if that cavity plate is a little too thick or it's a little too thin, things are going to perform differently than anticipated, and they may require some longer, deeper troubleshooting than necessary, or they may produce gate vestige or gate quality that's considered unacceptable or out of spec by the uh, by the end customer. So that's uh, that's part one. Part two is processing has a huge impact on gate quality, um, as do things like cooling and material itself. So if you're you if you're processing, let's say your hold time or your temperatures are too high, you might have a very difficult time closing your gates, or rather, you might have a very difficult time removing heat from your gates, which might give you some high gates or some glossy surfaces. If those temperatures are too low, it's going to be very difficult in a different way. If your cooling is too strong and you have a highly crystalline resin like a nylon, you are probably going to make tall gates, and you're probably going to slam your gates home and beat them pretty good. But the gate hole or the gate diameter or the gate orifice itself is also a huge contributor to it. If that gate is is not round enough, it's not perfectly, it's not deep enough, or there's an inconsistency from cavity to cavity for something like that, that's also a huge contributor to that gate quality too. So it's not just the hot runner, it's also how that gate is made and how it's interfacing with the cavity.
All right. I want to remind everyone we do still have about 10 minutes, so there's still time to post or place any questions you have for Derek in the Q&A panel, so feel free to do that. Can we have surface defects when we use a valve gate system, and how can they be prevented?
Yes, that's
Quite
that's
open-ended.
that's very open-ended. You can have surface defects with a lot of things, and it all depends on how you use that tool. The hot runner and the valve gate are a tool that's being used to make those parts. If that hot runner isn't being used properly, that's you're going to have some real challenges with surface defects. If that mold is not well designed, you're going to have some problems with surface defects too. Surface defects, I think we all know that we could all probably write an inch thick book about various surface defects that are out there, and the list of causes of those surface defects is probably even thicker than that. But a valve gate, it can be used to solve those defects, but it can also, if improperly used, be just as much a part of it.
Um, can can you use gate tip insulator in the existing hot runner system?
Um, for a question like that, I would say my interpretation of a question like that is, can you take your gate tip insulator or your tip insulator and use it again? I would recommend against doing that. That's because those tip insulators, their purpose is to consume volume in the gate bubble. The way that they do that is they are made out of a relatively softer material um, that has a relative sturdiness to those operating temperatures. Um, but what happens is those insulators will creep or deform over time. And when that happens, the next time that they're used, um, just like a gasket, uh, just like a piston seal, those are permanently deformed. The next time, if those are used again and again, there's a very high risk that those could crack. And when those crack, those cracks create stagnation areas inside the melt stream. And when you have stagnation areas inside the melt stream, that creates a very high risk um, for for burn streaks, for burps to pop up where either old color bleeds into your part, or burning can bleed into your part. And if that's something that you aren't aware of, that could be a really, really difficult thing to troubleshoot when all you really should be doing is replacing the parts when they should be replaced, which is every single time you crack it open.
What would you say, Derek, is the most common problem with a hot runner system that could be minimized or eliminated if they just followed a certain refurbishment or maintenance program with the system?
Um, Quite a lot.
Yeah. Is there
That's,
one that stands out, like a big one that you hear that you experience all the time?
you know, not really,
Okay.
because different things happen with different types of systems.
Okay.
It's just like a lot of things that we have in our lives. Vehicles are always a really, really good one. If you if you don't take care of your vehicle, you might need to buy a newer one a lot sooner than one that you take care of. If you change your oil every 3,000, 5,000, whatever they call it now, you're going to get a lot more mileage and a lot more life out of something like that rather than just uh, beating it and neglecting it.
Yeah.
I would say that really a big one is you you know it's really just operating life, and it's really things like imbalances. Heaters are a really, really big thing.
Okay.
They're an electrical component,
Yep.
and the molding environment is it's a pretty aggressive environment. There's a lot of humidity. There's a lot of heat. Uh, Electronics don't like operating in those too much. And if there's a water leak, or things get um, too hot being relative, that can really make things fade out a lot more quickly than expected.
Okay. All right. Should cavities which require heat treatment have the gate hole created after heat treatment or before? And what process does Husky recommend to create the gate hole, if not by EDM spark erosion, which is usually discouraged?
That's a bigger question that we should probably go over one on one.
Okay. We'll leave it there. All right.
Yeah, let's do that.
What may be the reason for a thin flash like projection in the hot tip, which is happening for this person randomly and not in every shot? The material is polypropylene with 20% talc filled.
Wow. I don't think I could give a full-blown solution, but if that's a Husky hot runner working on something like that, I would say that's a much better question to go to our call desk with, rather than trying to troubleshoot it in public
Okay.
right here in front of everybody else.
Fair enough. Fair enough.
Yeah.
So, what is the difference between factory supplied hot runner parts and third party hot runner parts besides cost?
Um, that's the, the the big answer to a question like that is we don't know, because we don't know what's in those third-party parts.
Okay.
We don't know how they're made. We don't know we don't know what's in them. They could be the same on the outside, but up close and personal, there could be longer lands, shorter diameters, different hardnesses, and different materials. Quite frankly, all of which can affect how effective they are, especially if you're going one to one comparing them with each other.
Okay. What purging compound do you recommend when doing color changes with hot runner systems?
That's I'd say that's a better question for a purging compound supplier. We recognize that they're out there. We've even done some webinars in partnership with Chemtrend with their
That's
Ultra
right.
Purge
Right.
product. So we know that they're very good, but the other purging compound suppliers out there also make a very good product. All of which are also application dependent. All of whom have their own application engineers to talk about those very, very specific things.
If a tool with a Husky system has moved to a different molder several times or different molders several times, and all the original documentation is lost, what is the bare minimum? It's kind of what I was getting at before. The bare minimum information required for Husky to be able to service it or provide replacement parts.
That's uh, that's not a problem. So
Okay.
it if you have a Husky system, somewhere on that Husky system is going to be uh, there's going to be a project number. That's very typically a 6-digit number. At least it was starting in the early 90s and moving forward. If you can find that 6-digit project number anywhere
Hmm.
on the hot runner, that's going to be the first clue for finding out anything else about that hot runner. From there, we can find drawings, we can get bill of materials, we can find original application intent, all of those things to get that information back over to you.
That's good information.
Yeah.
They're never
Yep.
lost as long as it's a hot runner, a Husky hot
That's right.
runner.
Yep. All you need are 6 numbers in a row,
Yeah.
and you're probably back in business.
All right, you talked a bit about outsourcing the refurbishment and maintenance to Husky. Someone is asking, I know what the general answer is, but can I perform a hot runner refurbishment in my own tool room by myself?
Yes. Um, it is that all really depends on the short answer is yes. The long version is how quickly can you do it and what can you expect. That's all going to depend on your experience and the experience of your teams and the the resources that you have available. You're definitely going to need a crane and you're definitely going to need a lot of wrenches in order to make that happen, but you can do it. It's all just a matter of, do you have the people, do you have the floor space to do it? Myself, I recommend, if somebody wants to perform a hot runner refurbishment themselves, that's great. I think I think that a lot of people, I think that would help a lot of people to understand and appreciate what's going on inside
Yeah,
that hot runner. But one of the things that I encourage is to send your manifolds out for a cleaning and inspection, and that's just because drilling plastic out of melt channels can get to be pretty can get to be problematic. You can scratch or scour your melt channel finishes. Um, that can create stagnation areas, which can jump out of the bushes and ambush you later on as other problems to troubleshoot. And it's just a lot more thorough to get all of the material out of there rather than just what's on the surface.
got it. All right, Derek, that about wraps it up. That's a good note to end it on. So I want to
Great.
thank you for your time today and for this presentation and for answering all those questions.
Yeah. Thanks for having us, Christina.
All right. For those listening who would still like more information, feel free to contact Derek. His information is right there on the screen, his email address, to contact him personally. And I want to thank the organizers, Abby, for helping this webinar run smoothly today. Go team. And most importantly, I want to thank everybody out there for listening. And remember, you can visit moldmakingtechnology.com for this webinar and all of our archived webinars. This concludes today's webinar. Again, I'm Christina Fugis with Mold Making Technology, and have a great day.
Thank you, everybody. Take care.